Hi, welcome back to Unit 6, Day 3. This is example 2. So in the previous example, we went over example 1, and I just want to remind you of the steps that we use to solve these one-step conversion, mass to mole conversion. So remember, we'll first start by reading the problem, identifying our given and find. Then we sort of map it out, rewrite what we're given, then an arrow going to what we want to find. Then we determine the appropriate conversion factor. We set up our dimensional analysis using this sort of as a guide, and then we solve. Now, a lot of these steps may seem superfluous, like what's the point of doing it? It just seems extra. But the reason why I'm doing it this way is because when we get to two-step conversions or stoichiometry, these sort of habits that we're developing now will be super helpful to helping us understand what we're doing later when things get complicated. Okay, so with that being said, let's go ahead and tackle this problem. So this next problem says, how much does 0.39 moles of NH3 weigh? All right, so I've read the problem. So I know I want to know the mass of 0.39 moles of NH3. Remember, when you see a word like weigh, I'm just going to add that to my notes. And by the way, the notes that I'm writing down, you should include also. If they're helpful. So when you see something like weigh, that means that they're talking about the mass. All right, so in this problem, identify my given and find, I'm given my moles, and I'm trying to find my mass. And I know I'm looking for my mass because they use the keyword weigh. So again, I added that note, weigh means mass. Okay, now that we've done that step, the next thing we're going to do is map out our plan here. So our plan is to go from moles to mass. The next step is to determine the appropriate conversion factor. So we're lucky in this case, since we've only looked at one of these types of problems, all the conversion factors are going to be the same. So the conversion factor in this case is going to be 1 mole of, since we're dealing with NH3 equal to whatever the molar mass of NH3 is. Now, because this is a molecule, I'm going to have to do that calculation. So let me go ahead and underneath here, just doing a little bit of scratch work, I'm going to put my molar mass of NH3. All right, so on the periodic table, I look for my nitrogen. NH3 has 1 nitrogen, so it's going to be 14, and that the mass of that is 14.01. So 14.01. And it has 3 hydrogens, so it's going to be 3 times the mass of hydrogen, 1.01. And when I do the math really quickly, I get 17.04. And notice I'm not using units here because this is just my scratch work. But up here, I'm going to put my units in. So that's going to be 17.04 grams of NH3. All right, so 1 mole of NH3 is equal to 17.04 grams. Okay, now that I've done that, got my conversion factor, now we're going to do our setup. We always start by the given over 1, so 0.39 moles of NH3. Now, it's important that you put the units, but I also like to put the type of substance that we're dealing with. Right now, it may seem like extra, but later on, that habit will be super helpful when we're doing more complicated problems. And again, we put it over 1 just to make this into a fraction. Notice that in this first case, since we're just making it into a fraction, the number underneath is just a 1 with no units. Okay, now the next step is to put our conversion factor here. Now, there are 2 parts to our conversion factor, 1 mole of NH3 and 17.04 grams of NH3. And I need to figure out what goes on top and bottom based on the units I want to cancel out and the units I want to keep. Now, in this case, I'm starting with moles of NH3, but in the end, I don't want moles of NH3, so I want to cancel that out. In order to cancel out moles of NH3, that means that the moles of NH3 must be in the opposite position. So in this case, it needs to be in the denominator. Since it's in the numerator in our given, on top and then in our given, it has to be in opposite the denominator or the bottom of the conversion factor fraction. So the part of the conversion factor that has moles of NH3 is this 1 mole of NH3. I'm going to put 1 mole NH3. Now on top would go what's left, the 17.04 grams of NH3. All right, which is our fine, so that's good because we'll get to keep that. And we'll see, since these are opposite, whoosh, whoosh, we can go ahead and take those out. Okay, so now let's go into our math here. For the math part, I'm just going to focus on the numbers, and I'll come back to the units in the end. So remember, when you're multiplying fractions, you multiply straight across. So 0.39 times 17.04. That goes on the top, so I just multiply the two numbers in the top. And then the bottom is going to be 1 times 1, which is just 1. I won't even worry about that. So what I'm doing essentially here for my math is I'm just multiplying those two numbers. And when I multiply those two numbers, I'm going to get 6.6. And then my units are going to be what's left here, my grams of NH3, which matches my find, right? I want to find mass, so grams of NH3, those units are appropriate. Okay. So, that's the answer for that one. So I'm going to add a little note up here at the top. Remember that the units must be opposite to cancel. And that's why we put the moles of NH3 on the bottom in this example, but the grams of aluminum at the bottom of this example, because the units we want to cancel must be opposite. All right, that's it for this video. The next video will be example 3.